Hello class, today we're going to look at lesson 7.2 on ratios, rates, and unit rates. Our objective for today is we can work with rates and ratios. So let's look at our first example. So we have an entertainment application. By design, movies can be viewed on screens with varying aspect ratios. The most common ones are 4:3, 37:20, 16:9, and 47:20. We need to order these from width to height, from least to greatest. So we're going to start by just finding out what are each of these ratios in decimal form. So 4:3. 4:3 is just able to be written as 4/3. And 4/3, if we do the division, is 1.3 repeating. Now let's look at 37:20. Well, we can write that as 37/20. And if we do the division, that's going to give us 1.85. Now let's look at 16:9. 16:9. We can rewrite that as 16/9, which if we do the division is 1.7 repeating. And then we've got 47/20, which is 47/20, which if we do that division will give us 2.35. So what's the smallest number we have up here? The smallest decimal number is 1.3 repeating, which means the least ratio is 4:3. So we'll list that first, 4:3. The next smallest number is 1.7 repeating. So we'll write 16:9 as our next smallest. Next we have 1.85. So our next ratio is 37:20. And that leaves then 47:20 for our greatest ratio. So we've ordered those ratios from least to greatest. Now let's look at example 1b. Example 1b asks us that, or tells us that a widescreen television has a screen width of 32 inches and a height of 18 inches. What is the aspect ratio of the screen? So we're going to take the width, 32, and we're going to divide it by the height, 18. Then we're going to ask ourselves, what number goes into both 32 and 18? Well, 2 does. So we're going to divide both of these by 2. (32) divided by 2 is 16, and 18 divided by 2 is 9. So the aspect ratio of this widescreen TV is 16:9. All right, we're done with example 1. All right, it's time for a vocab alert. So rate. A rate is just a comparison of two quantities that have different units. And then unit rates are just rates in which the second quantity is 1. So let's look at an example. So we're going to use a bar graph to determine rates. So the number of acres destroyed by the wildfires in the year 2000 is shown for the states with the highest totals. We're going to use the bar graph to find the number of acres to the nearest acre destroyed in each state per day. And in the year 2000, there were 366 days that year. So what we're going to do is we're going to first find the rate for each state. So in Nevada, there were about 640,000 acres that were destroyed that year. So we'll put 640,000 over 366 days. In Alaska, there were about 750,000 acres destroyed. In 366 days. In Montana, there were about 950,000 acres destroyed in 366 days. And then in Idaho, there were about 1,400,000 acres destroyed in 366 days. All right, now what we're going to do is we're going to find the unit rates. So we're going to divide the top number by the bottom number. So if we divide 640,000 by 366 to the nearest acre, that's going to give us about 1,749 acres that were destroyed per day in Nevada. If we divide 750,000 by 366, that's going to give us about 2,049 acres that were destroyed in Alaska per day. If we divide 950,000 by 366, that will give us about 2,596 acres that were burned in Montana per day. And if we divide 1,400,000 by 366, that will give us about 825 acres burned in Idaho per day. So we needed to find these unit rates, and now we're all done. So all four of these unit rates are our answers. Let's move on. So our next vocabulary alert, we have unit price, which is just a unit rate used to compare the cost per item. All right, so we're going to find unit prices to compare costs. If we have blank videotapes can be purchased in packages of 3 for $4.99 or 10 for $15.49, we need to decide which of these is the better buy. So to do that, we're going to take the price for a package and then divide that by the number of videotapes. All right, so let's do that with both packages. It costs $4.99 for 3 videotapes. If we find the unit price, that means we're going to actually do the division. $4.99 divided by 3 is going to give us about $1.66 per videotape. Now we're going to also do that for our other package we could purchase. It could cost $15.49 if we bought a package of 10 tapes. If we do the division, that's going to give us about $1.55 per tape. Now, would I rather pay $1.66 for one videotape or $1.55? Well, the better buy is the package of 10 because it's cheaper to buy one tape if we buy the package of 10. Let's look at one more example. So we have Leron. He can buy a 64-ounce carton of orange juice for $2.49 or a 96-ounce carton of orange juice for $3.99. Which is the better buy? So we're going to put the price for a carton of orange juice over the number of ounces in the carton. So let's start with the first option we have. We can buy a 64-ounce carton, so we'll put 64 in our denominator, for $2.49. So we'll put $2.49 in our numerator. We can do the division and estimate that it'll cost 0.0389 cents for 1 ounce. Now let's check that with our other option. We can buy a 96-ounce carton of orange juice for $3.99. If we do the math here, it's going to cost about $0.0416 for 1 ounce. If we were to round this, it really doesn't matter which one we buy, but in reality, we are still saving money if we buy the 64-ounce carton. So the 64-ounce carton is the better buy for $2.49. And that wraps up Lesson 7-2 on ratios, rates, and unit rates. For the rest of the evening, I would like you to work on the Your Turn problems in your guided note packets. See you tomorrow.